Okay, this video is a review of what we've done so far on radicals, and then also teaching you a new way to solve quadratic equations. So it's a combo. So if you've missed a day or two or you don't remember something, hopefully this review will help. So on the first problem, we want to simplify the radical. So this is where we're going to make the factor tree. So on 56, you may not know a factor, but you may know it's even. I guess 56 isn't that hard, but 2 and 28. 28's even, so you can do 2 and 14, and then you can do 2 and 7. Now remember, it doesn't matter what you start with. You're only going to be looking at the numbers at the end of the factor tree. Everything else gets ignored. And we're looking for pairs, so I've got a pair of 2's. Each pair represents one number outside of the radical. Anything not paired up gets put underneath the radical. And if you have more than one thing inside or out, it gets multiplied. So this is 2 square root 14. All right, let's try this with variables. 60. 60 is going to simplify to 6 and 10, 2 and 5, 3 and 2, only looking the numbers at the end. The 2 goes outside, the 3 and 5 goes inside. But remember, this is square root, so we're looking for groups of 2. So with the variables in 12, there are 6 groups of 2 with none remaining. In 5, there are 2 groups of 2 with 1 remaining. If I simplify that, I'd get 2x to the 6th y squared, square root 15y. All right, number 3. Number 3, when we're multiplying, you can multiply anything you want, except when you're doing it, when you combine them, you can only multiply numbers that are both in the radical or both out of the radical. So 10 and 14 are both in, so I can multiply, and I get the square root of 140. But we've got to simplify that. Lots of things go into it, but I know 10 and 14 have to, because I just used those two numbers. Okay, simplify it, I get 2, and underneath I have 5 times 7, so we get 2 square root 35. Number 4, same thing, but this time we've got numbers outside, so you can only multiply numbers if they're both outside or both inside. You can't mix and match, so that's going to give us 6 square root, and then inside you take 6 times 15, and we get 90. All right, now we've got to simplify the 90. Well, we know 6 and 15 works. 3 and 5, 2 and 3. Now, don't forget about that 6 that's outside. It gets to come outside. We bring a 3, and then inside we have a 2 times 5. So that's going to be 18 square root 10 for our final answer. Okay, number 5, we're squaring a monomial. And remember, when it's a monomial, you can distribute that exponent. So that's really 5 squared times the square root of 3 squared. 5 squared is 25, and the square root of 3 squared is just 3. If you have forgotten, remember, square root of 3 times square root of 3 is square root of 9, which is just 3. When you square a radical, it cancels it. Anyway, so 25 times 3, whoops, is not 73. Too many 3's going to 75, and there's your answer. Over here on number 6, 7 squared is 49. Square root of 6 squared is 6, so we have 49 times 6, which is 294. All right. Now, on 3 and 4, you're multiplying. You multiply whatever you want. But squaring, or excuse me, adding and subtracting, you can only do if they're like terms. And for radicals, you're only going to have like terms if you have the same number under the radical. So we're looking at these right now. None of them look like they're like terms, but we're going to have to simplify these radicals to make sure. So 12 is 3 and 4, 2 and 2. So we have the 3 from the outside, the 2 that comes out, and the 3 underneath. So I get 6 square root 3 plus 4 square root 3 can't simplify anymore because 3 is prime. 27, 9 and 3, 3 and 3. So I'm going to have the 5 that was outside, the 3 that can now come outside, and the 3 that's underneath. So this is 15 square root 3. And just kidding, that's not plus, that's minus. Okay, so now they're all like terms, and now I can find them. So 6 radicals plus 4 gives me 10, minus 15 is negative 5 square root 3. Okay, same thing on number 8. You got to simplify the radical first before you can determine if they're like terms and combine them. So 32 is 2 and 16, 4 and 4, which you could simplify further, but it's not necessary. So we get 4 square root 2 minus 9 and 2, 3 and 3. So 6 times 3 square root 2. So we have 4 square root 2 minus 18 square root 2, which would be negative 14 square root 2. All right, number 9 and 10, we are simplifying, but if you happen to remember, this is called rationalizing the denominator. And to do that, you're going to multiply top and bottom by the square root of 3. So on the top, we get 12 square root 3. On the bottom, the square root of 3 times square root of 3 is the square root of 9. The square root of 9 is 3. But these numbers here, because they're both outside the radical, can reduce. They can only reduce if they're both out of the radical or both in. So 12 divided by 3 is 4, so we get 4 square root 3. On number 10, I'm going to rationalize the denominator, multiply top and bottom by the square root of 6. So we have 14 square root 6 over 6. Only these numbers, because they're outside of the radical, can reduce. They have to be both in or both in, or both in or both out, just like you're multiplying. And 14 over 6 would reduce to 7 square root 6 over 3, and that is our final answer. Okay, so that was simplifying the radicals. Then we learned about quadratic equations. In quadratic equations, the highest exponent is a 2. And there's going to be multiple ways that we're going to learn how to solve quadratic equations. The first way that we learned was by taking the square root. And to do that, you need the x squared by itself, which it is on number 1. And to undo the x squared, we are going to do the square root. We know the square root of x squared is just x. And now we have to take the square root of this fraction. So you take the square root of the top and the square root of the bottom. Now on the first 10, we are simplifying, so we just kept everything positive. But now when we're solving, we have to account for both the positive and the negative, because every time you solve a quadratic equation, you are going to get 2 answers. Okay, number 2, we want to get the x squared by itself. We can't do that until we divide both sides by 2. So we get x squared equals 49. And now that it's by itself, now we can take the square root of both sides. So we get x equals plus or minus 7. Okay, number 3, we got to solve for x, but we got to get it by itself first. So I'm going to subtract 12 from both sides. So I get x squared equals 34. Take the square root of both sides. Now, 34, we want to simplify. We get 2 and 17. But I don't have any pairs. That means it's not going to simplify any further. So my final answer is x is going to be plus or minus the square root of 34. You can't remove the radical because we haven't taken the square root yet. Okay, so option 1 is to solve by the square root. Option 2 is to solve by factoring. And when you take your test, there's going to be a section for each type, and you're going to have to read the directions and know which type is which. Okay, when you are solving by factoring, it is a 3-step process. Step 1 is to set equal to 0. So you're going to set the equation equal to 0, because until you've done that, you can't factor. And the next step, is to factor. And the last step is going to be write equations and solve. Now, that seems like more than one thing to do. However, I think once you start practicing these and start doing them, this write equations and solve, it's effortless and it's not like an event. You just kind of write down the answer. Okay, so let's look at number 1. First step, set equal to 0. Good news. I already said equal to 0. We don't have to do anything. Step 2, factor. So notice this is different than what we did with the square root. Square roots, we weren't factoring anything. Okay, this is the difference of squares. So this is going to factor to x plus 6, x minus 6. So now it's factored. But notice these problems are different than the factoring ones because they have an equal sign. Now we're not just factoring, we're actually trying to get an answer. We're solving. So there's a difference, but they are still quadratic equations. They still have a highest exponent of 2. So that means we have to have 2 answers for all of these problems. Okay, so let's do that. So we just did step 2, we factored. Second equation, I can't talk. Third step is to write equations and solve. Now, if you multiply 2 numbers together, whatever 2 numbers they get, and your answer is 0, that means that at least one of them has to be 0. So the way we write our equations is we say, well, either x plus 6 has to be 0 or x minus 6 has to be 0. So now we can solve the equations. So this, you're just subtracting 6. This, you're just adding 6. This is not hard. So we get x equals -6 and x equals +6. 2 answers. Now, it is this step right here that by the time we do this a lot, you will not need to even write this down. You can just go from the factored form to the answer, because that's not very hard mathematically. You're just seeing what makes the parentheses equal 0. Okay, let's try it again. Step 2, it is set equal to 0. Step 3, factor. It's a trinomial. The leading coefficient of 1. I go straight to my 2 parentheses. I'm looking for 2 numbers that multiply to 16 and add to 10. Those 2 numbers would be 2 and 8. So I have +2 plus 8. So I did step 2, I factored. Step 3, write equations and solve. So either x plus 2 equals 0 or x plus 8 equals 0. So when I solve, x equals -2 and -8. Now, before, when we were doing the other ones with the square roots, everything was like plus or minus the same number. But now we're going to get 2 totally different answers. They're not even just going to change sign. They won't necessarily change signs. They're just different numbers altogether. Okay, let's try number 3. Number 3, it's set equal to 0. Step 2, factor. So I'm going to go straight to my 2 parentheses because it's a trinomial with the leading coefficient of 1. Looking for 2 numbers that multiply to 45 and add to 12. Well, 1 and 45 definitely doesn't work. 9 and 5 you probably think of a lot, but 9 and 5 doesn't work. But it is divisible by 15. 15 and 3 and 15 and 3 would work. So now I can write my equations. So x minus 15 equals 0 or x plus 3 equals 0. So when I solve, x equals 15 and x equals -3. Okay, and it's this step here that when you're ready, you can do it in your head and don't need to write out. I'm going to keep writing it out for a while so people understand where I'm getting the numbers. But as soon as you can make that jump, then you just write those answers down. Okay, now number 4, you might be tempted to take the square root of both sides. But this section says that we are solving by factoring, and taking the square root of both sides is not factoring. So we got to follow directions. Step 1, set equal to 0. Now, when we set it equal to 0, our x squared term has to remain positive. And if it doesn't remain positive, then this will not work. Okay, so it's positive now, so I'm not going to move it. So I'm going to subtract the 49. So that gives me x squared minus 49 equals 0. So that's step 1. Step 2, factor. It's a difference of squares. So that's going to factor to x plus 7, x minus 7. So when I solve, I get -7 and 7. So you might be thinking, well, if I took the square root, I'd get the same answer. You are absolutely right. You would get the same answer, but I'm teaching you different techniques on how to solve quadratic equations, because you're going to have some where taking the square root is the most efficient. You're going to have some where it's better to factor. Others, we're going to do quadratic formula. Some, we're even going to graph. So there's all these different options. So you need to have, I hate this expression, but you need to have all the different tools in your toolbox. You have to have all the different skills to be able to do whatever you need. Okay, let's look at number 5. And on your quiz and on your test, it's going to say in the directions exactly how I expect it to be solved. So we need to know the difference. Number 2, or just kidding, 5. First step, set equal to 0. It is. Second step, factor. So I'm going to go straight to my 2 parentheses. Because the leading coefficient is not 1, I'm going to guess and check. So I can't have x and x. I'm going to try 2x and x. And now I'm looking things that multiply to 21. Okay, well, 3 and 7 is probably the most obvious one. So I can see if that works. I don't know if I do 7 over here, that'll give me 14. This will give me 3 in the middle, and 14 over here, right? And if I subtract those, I will get 11. So that is indeed what I want. And I want it to be a positive 11. So I need the 14 to be positive. So to make the 14 positive, that was the 2 times 7. So this is the positive, and the 3 would be negative. So now when I solve, I'm going to say 2x minus 3 equals 0, and x plus 7 equals 0. Now this one we can all see is negative 7. This one takes a little bit longer for some people to do in their heads, but remember we're adding 3, so we get 2x equals 3, divide by 2, so x, oh my goodness, I wrote the wrong thing, divide by 2, so x is 3/2, and there is your second answer. Okay, let's try this again. Number 6, first step, set equal to 0. Okay, so we're going to set it equal to 0. But remember, when we do this, the x squared must remain positive. And when we write it, we always want it in that descending order. So it's x squared, x, and then the number. So I've got the x squared and the 5x. I'm going to subtract the 36 because my x squared is already positive, so I don't want to move it. So I'm going to have x squared minus 5x minus 36 equals 0. So now when I go to factor it, my two numbers would be negative 9 and 4 because they add to negative 5 and multiply to negative 36. So my equation would be x minus 9 equals 0 and x plus 4 equals 0. So x equals 9 and negative 4. Okay, let's try this again. Number 7. Number 7, it's not set equal to 0. But when we do this, we want to keep the x squared positive. And since that x squared is positive where it is, we are not going to move it. So instead, I'm going to subtract the 4x and I'm going to subtract the 28. And I'm going to write my answer in descending order. So x squared, x, and then the number. So I have x squared, 8 negative 4 is negative 12x, and negative 28 equals 0. Okay, I'm going to go straight to my 2 parentheses. Well, you think of 28, you think of 4 and 7, but that's not going to give us 12. But I could do, 2 and 14? That could work. So what if I did negative 14 and positive 2? Now, if you need to, write your equations. If you don't, go straight to your answer. Straight to your answer and get x equals positive 14 and x equals negative 2. I am not going to require that you write this line, but you need to know that's technically what you're doing. Okay, one last one. We need to set it equal to 0. And anytime we set it equal to 0, this part has to remain 0, or excuse me, positive. So that means I need to subtract the 14x. And when I do that, I have to have it descending order. So I have to have the x squared term first, the x term, and then the number. Okay, it's a trinomial. The leading coefficient is not 1. So I got to guess and check. I can't do x and x, so I'm going to do 3x and x. Things that multiply to 24. Well, I've got 1 and 24, 2 and 12, 3 and 8, 6 and 4. Okay, we got lots of options. Let's try 4 and 6. Where does this get us? That's going to give us 18x and 4x. Oh, would that work? Ooh, it would. Okay, I need the 18 to be negative, so 3 times 6 is what gave me the 18. So this is going to have to be negative 6, and this is going to have to be positive. All right. Now, when I write my equations, over here I just get, equals 0. X minus 6 equals 0, so x is 6. Over here I have 3x plus 4. what is happening? Equals 0. So let's try and do some of it in our head so we can get better at. First, we have to subtract the 4. So if I subtract the 4, I'm going to get 3x equals -4. Then I'm going to divide by 3. So that's how I'm going to get -4/3. So they're always going to be the opposite sign. And then you go from there. Okay, after you finish these notes, then you need to complete your homework. When you're done with your homework, you need to turn in both the notes and the homework to the sub, and then you have no additional homework for the weekend.